Hi, good morning, and welcome to the ZP FoodSense webinar. So we like to do this webinar every month, and it's really just a way of sort of showing, commitment to the product and to show that we provide training. So what we're going to, just a couple of things I want to say as we dive into this is that everyone who's a FoodSense user does get personal online training. So people, sign up for FoodSense, people receive the hardware. We make sure that they've kind of got the app on their phone and they're making this kind of Bluetooth connection with the device. And then we get online with them and we, sort of do a demo, but also make sure that they're, able to use the device as well. So everyone is getting essentially, how do I say it, one-on-one help. So everyone gets personal online training. We also back that online training with also a weekly webinar. So every Wednesday at 8 a.m. London time, we do a webinar where we answer questions that have come in during the week, questions that come in, the most common questions, and they'll be addressed today are what dilution should I use with the FoodSense? And also people are kind of interested in repeatability as well. If I if I do multiple samples, what kind of repeatability will I expect? And I'll address that as well. So I suppose there's kind of 3 tiers of support in some ways, or at least 3 activities going on every month to support foods. We do these live demos. Here we are. We're all here today. We do weekly webinars, and we also do personalized training for everyone who's a user. I suppose you'll get a sense of that on that training today when Solrun does her demo. So first of all, just to say for September, we've set up all the webinars already. There's no need to watch them live, and because they're all recorded, and there's no need to watch them unless you've actually got a question. I'm just going to do a very quick introduction to ZP and just say that ZP was launched in 2014. So come November, we'll be 9 years old. We are ISO 13485. We're very, how do I say that? I don't want to say strict on it, but we are strict on it that, this means something to us at ZP in terms of, we're qualified to develop and manufacture electrochemical products or electrochemical biosensor products. We do a lot of contract development, contract manufacturing. We are not a big company, but we're not a small company either. We're we're literally classified as a medium-sized company, but I think a small medium is, to be fair. I don't want to overstate us. We're primarily active in the UK and Norway, so I've got a couple of colleagues on this morning. I'm in the UK, Niti is online, and Solrun, who's also in the UK, and Solrun is in Norway. Team's big, international. Well, team's fairly big. It depends on relative things, but I think in this photo, there's something like 65 people and 25 languages spoken between them. So like any modern company, pretty international. We do have multiple sites, so we're not sort of all located in one building. So we're sort of quite a disparate team, but obviously with modern technology, we're all able to stay in contact with each other. We are here specifically to talk about FoodSense this morning. And I'm wondering, and I hope that I'm not missing the mark, that we're going to primarily talk about FoodSense for chili sensing. But I did also include a video about ginger sensing as well. We're going to do a live chili demo. And we haven't set up to do a ginger one, but just FYI, we do have people also using this for ginger as well. This is Professor Richard Compton. He's at the University of Oxford in the UK. Richard did a paper almost a decade ago now, if maybe even longer, about measuring the hotness of chili products. He was targeting capsaicin. Anyone who's kind of familiar with chilies, knows that this is one of the molecules, or the primary molecule for the hotness of chili products. This is the bit where it kind of ZP, we make what's called electrochemical biosensors. So you will not see this today, but the instrument is actually doing a piece of science called voltammetry. This is the voltammetry of capsaicin. So what's happening here is we're applying some excitation to the molecule. So when you see Solrun do the demo, in that sample, in those real samples, there's capsaicin, and we're trying to excite that capsaicin, and we're going to get a signal back. And the signal back, you can see that there's 3 peaks here. So you can see 1, 2, and a 3 here. These are indicative that this is capsaicin and not something else. And that also the peak heights are indicative of how much capsaicin is in the sample. So if I was to summarize what Richard did and what we, brought from the University of Oxford, he showed that voltammetry and electrochemistry and specifically the technique of voltammetry can be used to identify capsaicin, and actually we can also quantify the capsaicin. And you'll see the Sol run in her demonstration today. We'll test a couple of products and we'll have the Scoville heat unit for those particular products. Now, obviously, you have alternative ways of measuring capsaicin. You have HPLC, high pressure liquid chromatography. It's not as reproducible, therefore precise as people think, and not necessarily as accurate as people think. There's actually a lot of sample preparation when you're doing HPLC. It's quite a procedure, and anything that has a lot of sort of manual steps in it, you actually lose accuracy along the way. It's not this massive criticism of HPLC. It's just, well, the cost of what it is. It's not as golden as people would otherwise think. There was Wilbur Scoville. So the Scoville heat unit, SHU, is named after a guy called Wilbur Scoville. He sort of developed a Scoville organoleptic panel testing. I don't think anyone's doing it. It's too expensive to do, and probably not that sort of super accurate. Guessing, I think most people are actually just guessing. If your position is the quality manager in a company that produces chili products, then you're probably the one signing off that the batch is good. But of course, it's what we would describe as a subjective test. You've very little backup. When a customer complains it's too hot, you've got very little backup that actually, it was within spec. At least with the FoodSense, you've got a objective. I tested it and I got this result, and it's demonstratable. Of course, that brings us then to FoodSense. So what is hotness? Hotness is, the subjective testing. So the Scoville test, Wilbur Scoville test, I would describe as subjective. The quality manager signing off on the product, having tasted it, I would describe as a subjective test. HPLC is objective, very expensive, very hard to implement, and not as reproducible as people would otherwise think. And we then have the other objective test, which is FoodSense, which we will describe today. I did mention that ZP is ISO 13485. So what we mostly do is make medical diagnostic products for people, for example, testing their blood in diabetes. When you look at that kind of medical product and you look at what the FoodSense is, you can see that actually FoodSense is benefiting from all that kind of medical technology. And that's partly what we do at ZP, is actually take things that are used in the medical industry, reliable, faster manufacture, and convert them into food quality products. We have actually tested at ZP. We do have an HPLC. We have a Waters HPLC system, and that means that we've tested against HPLC and our own product to make sure that we can align or correlate, let's say, with HPLC. Having done that, you realize that the HPLC is not what people think it is. People take a sample, they send it to the HPLC lab, they get a certificate analysis. Very, very rarely is there actually an error given with that. What I mean by that is, if your product says 15,000 Scoville heat units, is that exactly 15,000 Scoville heat units? Because it's not, because there's always an error associated with that reading, but people just get this absolute number and they believe it, and that's okay. But having now run the HPLC method for several years, we realize it's not as great as otherwise people like to think. Now, it's no point me telling you I think this product's good. I mean, there's some independent validation here. First of all, this has come from the University of Oxford in the UK. It's a pretty prestigious university. I think it's easy to say it's in the top 5. You've got Oxford, Cambridge, Stanford, Berkeley, MIT. I don't want to list just UK and US universities, but those ones that come to mind quickest. But we've actually had academics also buy this. I think this is Charlie Stroher. he's bought this. He's nothing to do with us. He bought it and he tested it, and he tested it against HPLC. So he's a independent guy. He's essentially a customer of ours. He's at the University of Minnesota. I think he was actually quite impressed because he was using it to monitor whole chilies. And he said, well, look, I was able to get your product. I was able to make myself a chili sort of puree. He sort of blended it all up and tested that, and tested it against our system and tested it against HPLC. And I think the thing that has impressed him is that he could only test once on the HPLC because he couldn't afford to run other tests. Simply couldn't afford it. It's like, $100 in the US to do that, depending in the world where you are. But it doesn't get much cheaper because it's actually quite a laborious process for the person doing the test. He did one test, but he was then able to test the same thing in triplicate on the FoodSense. So he was able to actually get more certainty in the FoodSense number than he was in the HPLC number. And actually said, look, they really track quite well anyway, but I like he liked the speed of use, the low cost, and the fact he was able to do multiple tests, just to make sure that he was kind of confirming. I do have a link to that here. FoodSense. We have a blog post, HPLC determination of capsaicin and FoodSense. So I do have that original paper is available. Just to say that we do get a lot of people to say, well, this is my HPLC result. This is your FoodSense result. I say, look, HPLC isn't what you think it is. If you took the same chili powder and sent it to a lab, you'd get a certificate of analysis. It looks very official, very nice. Somebody signed off on it. Take the same sample, send it to a second lab, you'll get a nice certificate. Somebody signed off on it. Great. Send it to a third lab, you'll get a nice certificate. Somebody signs off on it. All great. So it gives you a paper trail, but actually if you line up all three certificates, you will have three different results. Absolutely no doubt about it. You won't get 50,000 Scoville heat units from one lab, 50,000 Scoville heat units from the other lab, 50,000 Scoville heat units from the other lab. You will find that actually each lab will give you three different results. Now you're hoping that one of them doesn't give you 100,000, the other one give you 50,000. You hope that that doesn't happen. But what you're paying for is not the precision that you think that you're getting. You're just not. Now, I think it's a little bit more than that. If you took the same sample and 1 month sent that chili powder, for example, to a lab, you get a nice certificate of analysis, and you're essentially kind of let's say happy with that result. Take the same chili powder and send it to the same lab but with a different name, because people are smart. Different name, so it's not traceable back to the to the original sample you sent in. You get a certificate of analysis. Great. If you send it on a third month, different name, you get this third certificate. You'll get three certificates. None of them will match up. And so I'm just saying to you, be careful, because we get absolutely this all the time, that HPLC is this amazing method. It's not. Solubility of capsaicin. This is one of the big questions that comes in. Capsaicin, the guys that are online today, you're going to know this. It's not amazingly soluble in water. It likes fats and oils, but it's not soluble in water. So what you'll see is when Solren's doing her demonstration, if she has a mild sample, she may do a 1 in 10 dilution. And if she thinks the sample is hotter, like a powder or whole chilies, she'll do something like 1 in 100. She's not going to do 1 in 1,000 today because we don't have anything exceptionally hot. But just know that the reason that we change that amount of solution is because capsaicin fundamentally is not soluble in liquids. But the buffer that we send out with this product, we want it to be, I do not want you to drink it, but if I spilt it on myself and it got in my mouth, I would be perfectly fine. So it's not actually toxic. And this is important because it means that you can use it with less trained people. Once you start including organic solvents, it becomes a flammable hazard or a toxic hazard. But the materials that we send out with this product are not toxic. So we send out water-based systems. Capsaicin is not terribly soluble in water-based systems. It loves fats and oils, then it can dissolve up nicely. So when we do a mild sample, you'll see Tabasco sauce today. We'll do a 1 in 10 dilution. I just want to say that somebody's just joining now, but don't worry. If you're signed up for this, I'll send you a recording later on today. So don't worry if you've missed the first half of this. Don't worry. That said, if it's a mild sample, we know that capsaicin is not terribly soluble in waters. So in fact, we do something like a 1 in 10 dilution because we want to dissolve all the capsaicin, but we know it takes a little bit of volume to dilute all that capsaicin. If we think it's hotter, something like 50,000 Scoville heat units, we'll do a 1 in 100 dilution because we know that capsaicin is not terribly soluble. So we need a bit more buffer to actually dissolve it in. So that's why we change the buffer volume. Fundamentally, capsaicin is not soluble. We don't want to put organic solvents into that buffer because once you put organic solvents into it, you've got a more toxic material. You don't really want a toxic material in a food processing plant. And also it gives you more of a headache when dealing with your guys, with your employees. You've got a burden of care on these people. That's why we changed the buffer. Now, a little bit of an update, and I'm sorry if some of you have come for ginger today. Email me back because I'm pretty sure that you've made email contact with either myself or Niti. But I do want to say that actually the technology now is also able to do ginger. Today we're only going to talk about the chilies, but it's just to know that the platform is increasing its capability. I think this is a ginger shot, and this is Solrun testing ginger. Probably if you Google ZP and ginger, you will find out about that. If you want to see this again, or you want other colleagues to see this, just know that there is actually a repeat of this webinar this evening at 4 p.m. London time. But also we do have some new webinars set up on the 26th of September 2023. Right. So now it doesn't matter if you came in late because actually the most important part is that we're going to do some demos. So what I'm going to do is turn off my screen and stop sharing. And we've got today Solrun and Soha are our quality manager. So I'll stop sharing. If you become a ZP client, Soha will be reaching out to you and we will be organizing a first training session with you. So thank you. Morning, guys.
Good morning. Good morning. All right. So as Martin said, I will be running a demo on how to test some chili samples. So I got some different chili samples for you today, but we will start off with the Tabasco because that's a quite homogeneous solution. It's easy to test. And it's not as spicy as a lot of other sauces we would work with. So what I will do for Tabasco is that I will add some Tabasco into a Petri dish, just so that it's easier for me to pipette it. And what I'm doing now is preparing my sample for testing. And your sample extraction is a quite crucial step of your chili testing, because let's say you will test chilies or a chunky salsa. So how you prepare your sample is important to allow it to get all the time it needs to extract, for instance. We also have some chili pop buffer, CP chili pop buffer. And what I will do right now is I will make a mixture ratio of 1 to 10. So I will add 1 milliliter of the chili pop buffer into this vial like that. And then I will add 100 microliter of the Tabasco sauce. Just need to adjust my pipettes, and I will give you a close-up. So this is just a chili pop buffer. It's looks like water, and then what I will do is so I added some Tabasco sauce in here. Yeah, you can see it from the edge, so I don't pour it all over my computer. And then I will use the pipette to just pipette it like this. So here is it. Then I will add it into the vial like that. Okay, and now I will show you what it looks like. So Right now, separating the Tabasco is going down to the bottom. So what we need to do is to mix it. And this is a part of the extraction that I was talking about. So we will use a vortex like this. And vortex is just to make it easier for us. And it's just cheating instead of mixing it by hand. And it gives you a homogeneous sample pretty quick. So since this is Tabasco and in itself, it's quite, it's a nice liquid and homogeneous, I don't need to mix it for that long. So now I'll show you a close-up again, and you see that it's all homogeneous and mixed out well, and you see like some chunks and bits from the Tabasco as well. So what I will do now I have my sample ready. So now it's for me to prepare my system or my device.
When you're doing that, so if it's chunky, how long do you think you need to mix?
So depending on the sample, like if, for instance, I would work with a chili, like the fruit itself, I would try to mince it up as good as possible so that I will reduce that extraction time. I will put it into the buffer. I will mix it using a vortex, and then I will actually let it rest on the bench for, let's say, 1 hour or 24 hours overnight, if that's, but I'm making sure to be consistent that I do the same every time. But what we see is that when we have quite chunky samples, is that if we test it right away, the pungency will increase over time just because you didn't allow it to extract.
Yeah.
Okay. So now I have the FoodSense device, which looks like this. So what I will do is I will insert a sensor, one of the chili sensors, like this. I'll show it up close. So you might notice that I'm making sure not to touch the electrodes of the sensor. So this part. So don't scratch the surfaces of the electrodes, or so always touch like the contact pads or the side of it. So what I will do now is I will insert it into the sensor like this, and making sure to push it all the way in like that. Okay, and then I will pipette onto the sensor. Okay, let me actually do this. So I will pipette my sample onto the sensor, and I will pipette 50 microliters because that's sufficient for the tests. Okay, so 50 microliters like this. And if you do get some chunks and bits into your pipette tip, that's okay. Okay, so pipetting it onto the sensor like this. And okay, now I'll be really careful for the liquid not to go inside the connector, so don't do this, but just for you to see, like you see that there's like a bubble forming on top of the electrodes there. Yeah, so I'll put it back down. So always make sure that it's on the horizontally placed on a firm ground. Okay, so actually this morning I just ran into some Wi-Fi issues. I tried to resolve it by connecting to another Wi-Fi spot, but in that I wasn't able to do the screen recording. So a bit backwards, but I will show you the screen using my webcam. So sorry about that. But this is the FoodSense. Well, this is the FoodSense app, and you see here that's a ratio of 1 to 100. And maybe I should actually even so that you see the right. Let me see if that's possible. Okay, I'll work on that later. Okay, so here's a 1 to 100, but we made a 1 to 10 buffer ratio. One part of the sample itself and 10 parts of the buffer. So I just adjusted that, and then I will click measure on that. No, on the phone like that, and then it will start running. and it will run for about a short minute. And what it's doing right now is what Martin showed you with the cyclical tomograms. So it's running through, and it's applying a voltage, a potential onto the sensor, and you get these peaks, and it will relate the peak heights in the area below the peaks to the concentration of capsaicin in your sample. So that's why we get different results depending on the samples themselves. So right now it's coming to a stop. And it came out as 6.5. And then we will run a 4 more spicy sample than this one. So another thing for you to remember is that capsaicin very much like the surface of the electrodes. So let's say you would test your sample, and you would test one sample, leaving it on there for a minute before you measure, and then another sample you would just test right away. Those two samples will come back with different results, and it has to do with the capsaicin attaching and the access for the electrodes to the sample itself. So be sure to be consistent on how much time you allow for the sample to be on the sensor. So right away, when you put the sample on the sensor, test it right away. Like right now, I didn't do that because I wanted to show and tell what I wanted to do. So normally you would just pipette the sample on there and then test it. So in order for us to do to test the next sample, I need to do some sample preparation again. So I trashed the sensor I just tested, and now I'm inserting a new sensor. And the reason why we trashed the sensors are they're a one-time use sensor. Again, the capsaicin do love the surface of the electrodes, so it will attach, and therefore if you run the sensor multiple times, you will get higher and higher pungencies due to that. So what we will do now is we will test a much more spicy sample, and because it's much more spicy, and because of the solubility of capsaicin, we will do a 1:100 mixture ratio. So I will add 10 milliliter of the buffer into the vial. That. So that's 10 milliliter. And then I will pour some of this chunky salsa. I can actually show you that it's a bit more chunky. Like if you look at the Tabasco, yeah, this is what the Tabasco will look like. As for this one, it's a lot more chunky and it has more bits in it. So I will add some of this salsa into a Petri dish again, so that it's easier for me to pipette it, and I won't contaminate my sample either, like that. Then I need to pipette my sample. Yeah. All right, okay. So pipetting my sample.
Same amount as well?
Yeah, no, this time it's 100 milliliters. So yeah, 1:100 ratio. So I just need to adjust my pipettes. That, and then it's harder to pipette up a more chunky solution, and then that for Tabasco. So just be patient, and that's also an advantage if you do prepare a sample so that it's more homogeneously mixed. It's easier for you to pipette it, but if you have a very chunky sauce, it might actually be more convenient for you to weigh it out using a scale. So that's also a possibility. And in some sense, it would be more accurate at times, especially if it's chunky sauces to talk about. So I will add it into the solution, the buffer, with that, and I'll show you up close again. So it's falling down to the bottom like that, but we want it to mix well into the solution. So again, I will use the Vortex. Since this is more chunky than the Tabasco, I would normally give it more time on the Vortex, but I would also maybe even let it rest on the table for an hour before I would test it, just to make sure that all the capsaicin has been extracted into the buffer. Okay, so now it looks like this, and you see that it's fairly homogeneous, and you see some chunks and bits in there, but that's okay. So we will now apply the same amount onto the sensor, so 50 microliters, and yeah, yet again, be careful so that you cover all the electrodes and also don't scratch the surface. So I'll pat it. I'll show you up close like that, by patting it onto the sensor like this. And then normally what I would do is just hit the measure button right away. But I want to show you that what I want to do is I will adjust this ratio to 100 because this is a spicier solution. And so that we are within the range of solubility, and then I will click measure. And then now it's running through the sample, and I expect this salsa to be spicier than that for Tabasco. So, and then the peaks of that cycloglutamate will be higher, and the area below will be greater surface. So yeah, let's just give it a quick minute. So yeah, as I said, repeating myself, but your sample preparation is crucial. So now it's finishes, and here you see that we have a Scoville heat minutes of 12,000, so twice as spicy as our last sample. All right.
Yeah, well, thanks very much, Solrun and Soha. I really appreciate it. And actually, something that came out the other day, we did a special webinar for colleagues in China, and there it was actually quite interesting, because when we're sampling from the tube, Solrun she's not putting the pipette at the top of the liquid or at the bottom of the tube. She's kind of going halfway in the middle. Because if she goes down to the bottom, it's full of chunks. And if you go up to the top, it's sometimes full of oil. But we actually want the liquids. We actually go halfway into the tube and kind of try and sample in the midpoint of that volume, but small matter. So if you didn't catch all of today's webinar, or actually you want to rewind, don't worry, it's all recorded. When the meeting ends, a recording comes to me, then we'll post it and we'll email you out a link. So I just want to say thank you so much to Niti today, who's helped organize this, also to Solrun, who's done most of the demos, and also to Soha, our quality manager. If you become a client of ours, then you will be meeting myself, Solrun, and Soha again in the first instance for that sort of one-on-one training. And then also don't forget that every week we do a special webinar just to answer questions from the week. And the questions that you'll send to us are, how much buffer should I use? And you'll be asking us about repeatability, and you're also asking us about comparing to historical HPLC. So we do understand the questions, let's say. So if you have any questions for us now, you have Neeti's contact details. You have mine. If you don't have mine, you'll find them shortly because I'll be sending you out the link to the webinar. So thanks so much to the ZP team. Thank you so much for attending this morning. And as I say, we're doing this again in September if you want to have colleagues join along and follow along. Okay, thanks very much. Take care, everyone.